Hello, in this video we're going to be talking about the rules for multiplication and division and addition and subtraction when dealing with significant figures. So in any calculation, anytime we have a multiplication or division, we're going to use one set of rules for those significant figures. And anytime we have addition and subtraction, we're going to use a different set of rules for calculating those significant figures. Now, when you have a multi-step calculation, you're going to have to be following along the entire calculation with the number of SigFigs because they change all the way throughout the calculation. So you can't simply plug in a number into a calculator and get an answer out with the correct SigFigs. You now have to follow every single step using the PEMDAS notation, PEMDAS operations, in order to identify which calculation comes first, and then use the correct SigFigs for that calculation, and then each subsequent calculation you have to use the correct SigFigs for those. So let's talk about the rules for addition and subtraction, and then addition and subtraction, and then multiplication and division. So let's start with multiplication and division. So here we have two numbers, 2.5 and 8.000. Now we already know how to assign significant figures, so here for the 2.5 we know both of those numbers are non-zero digits, so that means that this thing has a total of two significant figures. The 8.000, these have one digit and one non-zero digit, which definitely is significant. Now that since these three zeros are trailing and there is a decimal point, they do count, so 8.000 has four significant figures. Now if we plug this into a calculator, we get a number of 20.00. This is what you would get in a calculator. Now for multiplication and division, our final answer in a calculation has to have the same number of significant figures as the least number of significant figures within that calculation. So what does that mean? Since we have two significant figures for the 2.5 and we have four significant figures for the 8.000, our final answer can only have the least number of significant figures, which is 2. So 20.000 has four significant figures, so this is not correct. What we would have to do is we would have to drop off those last two zeros, keep the decimal point, and now we have a total of two significant figures. The 2 is significant, the 0 is significant because there is a decimal point. So we have two significant figures here. So again, for multiplication and division, doesn't matter if you're doing multiplication or division, anytime you do either one of those operations, you take the least number of significant figures from the calculation. So since this had 2 and this had 4, we take two significant figures. So that's the rule for multiplication and division. For addition and subtraction, it's slightly different. Here we have 2.5 plus 8.000. If you plug that into a calculator, you get 10.500. This is what you would get inside of a calculator. Now again, we can assign the significant figures here. There are two significant figures for 2.5, just like there was above. There are four significant figures for the 8.000. So how do we identify the number of significant figures in our final calculation for addition and subtraction? Well, we don't care about the total number of significant figures when dealing with the calculation. We only care about the number of decimal places. So not only do we have to identify how many significant figures are present, we have to identify the total number of decimal places. So here, 2.5 has one decimal place. 8.000 has three decimal places. DP, decimal place, SF, significant figure. When you do an addition or subtraction, your final answer can only have the same number of decimal places as your least number of decimal places within that calculation. So let's see how that works. Since this has 2.5 has one decimal place, and the 8.00 has three decimal places, our final answer can only have one decimal place. I'm going to put a bar above that. What that means is I have to erase these last two zeros, and our final answer should be 10.5, one decimal place. Now, you may notice the 2.5 had two significant figures, the 8.000 has four significant figures. Our final answer now has three significant figures. Doesn't match anything from the left, but that's okay because it has the correct number of decimal points. It has one decimal point. So the rule for addition and subtraction is different than the rule for multiplication and division. Whenever we do an addition or subtraction, we're looking at the number of decimal places, not the number of significant figures, we don't care what the final number of significant figures are at the end of an addition subtraction. We only care about the number of decimal places. So to recap, for multiplication and division, your final answer has to have the least number of significant figures from the calculation. For addition and subtraction, your final answer has to have the least number of decimal places from the calculation. So those two rules we're going to be using extensively throughout the semester. We're going to be adding in a lot more complications as we go. So with that, I want to say have a great night. I'll see you all in class tomorrow.